dear students, how are you? I hope you're fine. Today we're going to talk about a new lesson. It's about polygons, and this is a very easy lesson, so let's start. We have here, when I talk about a polygon, we know that the polygon here, it's a geometric figure that consists of all segments, and at least we've got here 3 segments. Why? Because if I have here just 2 segments, so this is an open one, so the polygon must be closed one. Remember that. Here the segments here meets or intersects at what? At here end points. Remember that. We have here in this one, we have here, I said, at least 3 segments. So we can have more than 3. Of course, we can have more than 3 segments or sides. These segments meet only at the end points. So if we have this figure, for example, so this is not a polygon. This is not a polygon because they meet here too. So this is not a polygon. And if I have here this one, if I have here this one, this is not a polygon because we got here a curve. Okay, so we have here this is called the vertex, and this is the vertices, and this is the plural of this is called vertices. So the angles inside any polygon, this is what? This is interior angles. And the regular polygon has what? All sides are equal in length and all the interior angles are equal. Remember that. Okay, so equal means here in math we got here congruent, the same as equal. When a side of a polygon is extended, it forms an exterior angle. Remember this, my dear students. I will show you now. Okay, so we got here exterior angle if I extend here the polygon. An interior and exterior here angle at a given vertex are supplementary. Interior and exterior angle at a given vertex, and I want to show you now by drawing. Okay, remember that we have here something is called the sum of, this is important, the sum of interior angle measures in a polygon is what? If a polygon has n sides, it means that I have the number of sides. Okay, so n minus 2 triangles are formed, and the sum of the degree, okay, the sum of the degree measure of the interior angles of the polygon, n minus 2 all multiplies what? 180. So this is the rule? Yes, it is. Let's see together. What's the sum? And you'll find this is very easy now. What's the sum of the measures of the interior angles of the heptagon? So I have to know the heptagon. It's what? It's with 7 sides. Okay, so heptagon has 7 sides. So let's here n equals 7. So what's the rule? N minus 2 all over times 180. So 7 minus 2, the number of sides of my figure, okay, times what? Times 18. So we got here 5 times 18, 900 degrees. I have here another thing, which is what's the measure of each exterior angle of the regular pentagon. So guys, I have here another thing or another rule that I have to know. I'm going to here calculate the exterior angle of a regular pentagon. Pentagon means 5 sides, remember that. So n here equal 5. So the sum of the measures of the interior, interior angles, interior, it's the same. 5 n minus 2 times 180. So 5 minus 2 times 180. So you got here 3 times 180, you got 540. So each interior here angle measures equals what? Equals here we got here we have here for the sum of the measures, all of the measures 540. So guys, what's here the measure of each angle? He gives you here a thing, a very important information piece of information. He gives you what? A regular pentagon. This means that all sides of the pentagon and all angles of the pentagons are congruent, equal. So 540 divided 5, because the pentagon, each side is what is congruent or equal, and I have 5 sides and 5 angles, so each side is equal to the other and each also angle. So 540 divided 5, it will give you 108. Okay, this is easy. What about the exterior angle? He asks me here for each exterior angle. So the sum of the interior and the exterior angle, as I told you, it gives me what? It gives me 180. If you have here a polygon, whatever, what is it? I have here this polygon and I have here exterior angle. The sum of them 180. So you got here 108. So 180 total here, measure of the interior and the exterior together minus the interior angle, gives me 72 degrees. Very easy one, I think it is. Here he asks you here to have some practice. Okay, let's have here before practice something to study well. I have here the number of sides. Please study this well because you're gonna use them. The number of sides here 3, so the name of the polygon is triangle. The number of here sides 4, quadrilateral. 5, pentagon. 6, hexagon. 7, heptagon. 8, octagon. And 9, nonagon. 10, decagon. Why? Because we're going to ask you what's here the exterior angle or interior angle of a triangle, quadrilateral, and whatever you got. So let's have here some concepts to make sure we understood this. Here, if a polygon has n sides, number of sides, so n minus 2 triangles are formed. The sum of the degree of measures of the interior, as I told you, n minus 2, all multiplies 180. All multiplies 180. So let's have an example. Find the sum of the measure of interior angles of a heptagon. So he didn't give me the number of sides, but I know them. Heptagon 7. N minus 2 times 180. Put this in a bracket. 7 minus 2 times 180. Put the bracket. 5 times 180 gives you this what? Gives you this 900. Okay, so this is the sum of what? The sum of the measures of the interior angles. So we got here something very important to make sure we understood it. A regular polygon, a polygon that is equilateral. All sides are congruent. Equiangular, all angles are congruent. Equiangular, this is a new here name for you. So all angles are congruent, here equiangular and equilateral for the sides. Since the angles of the regular polygon are congruent, their measures are congruent. Remember this well. If I have here in any polygon the sides are congruent, so therefore I know that all angles here are congruent. Okay guys, this is very important because he can ask me for the exterior angles by saying this figure is congruent. So let's have this example together. I have here, can you see this? Snowflakes are some of the most beautiful objects in nature. Not that how they are regular and hexagonal shape. What is the measure of one interior in a snowflake? So he asks me about just here what? The interior here angle. Each here one or just one. So what should I do now? I should get here the total of them and then get just one. The total of them, we have here a pentagon. This is what do you think? No, this is a hexagon. Hexagon means 6. 6, so 6 here minus 2, all multiply the rule 180. 4 times 180 gives you 720. 20, 720. When I say 720, this is for the total. It's here regular or not? Yes, it's given regular, so I can get just one. So I will say 720 divided by, guys, divided here 6 angles. So it will give you 120 degree. So the measure of just one angle of the interior angles is 120 degrees. Okay, guys, remember, if I ask you here about the exterior angle of this one, 180 minus 120, because the sum of them are 100, here 80, so you got this one is 60, right? Okay, let's have this example. I have here what? Exterior angles. When a side of a polygon is extended, an exterior angle is formed, as you see here. And we know when we have here an adjacent line, so 72 plus what? 180 minus 72 to get this 180 all. Remember this, guys? Okay, so remember this, and this is very easy. Remember also, we got here something to say. In any polygon, the sum of measures of exterior angles, one at each vertex, is what? 360. So this will be here the sum of what? The sum of the measures of exterior, sum of the exterior, not exterior and interior. Here exterior and interior, but the sum of the exterior, 300 what? 360. Remember, my dear students, I have here the homework, okay, on your booklets you got. So you have here what? You have here this one. You will find here the polygons. Yes, this one. Okay, you will find the homework, page 153 for this lesson. Okay, guys, thank you for listening. Hope you understood everything. If you have any question, please send me on the SCL. Thank you. Bye bye.